Next, an efficient rectangular section has fixed hydraulic properties such as the perimeter, roughness factor, and the slope. Determine the percentage increase in discharge retaining the given hydraulic properties if the section is replaced by an efficient triangular section, trapezoidal section, the most efficient of all sections. So this time it is the perimeter that is fixed and common to all these efficient sections. So let's compute the percentage increase if we replace the efficient rectangular section by an efficient triangular section, trapezoidal, and the most efficient of all sections, which is semicircular. So for an efficient rectangular section, remember the perimeter is 4D, and therefore the depth of flow in terms of perimeter, which is fixed in this case, is P over 4. So Q equals area to the 5/3, S to the 1/2 over N perimeter to the 2/3. So let's use this formula so that we will not compute hydraulic radius anymore. The area of the efficient rectangular section is base 2D times D, so 2D square. Remember that? And replacing the value of D in terms of perimeter, which is 2 times perimeter over 4 quantity square, so it is perimeter square over 8. So substitute into the formula, Q of an efficient rectangular section is perimeter square over 8 to the 5/3, S to the 1/2 over N, perimeter to the 2/3. So perimeter to the 10/3 divided by perimeter to the 2/3, so power of perimeter is 8/3. And expressing the answer, simplifying 1 over 8 to the 5/3, that's 1 over 32 perimeter to the 8/3, S to the 1/2 over N. So this is the constant for the efficient rectangular section, for the discharge of an efficient rectangular section in terms of perimeter and slope and N. Now for an efficient triangular section, the perimeter, remember, is 2D square root of 2. The slant side, remember, is D square root of 2 times 2. So 2D square root of 2. The area is D square, if you can remember. So therefore, the depth is perimeter over 2 square root of 2. The area of triangle, efficient triangular section, is 1/2 of 2D times D, so D square. Then replace D square by P over 2 square root of 2 quantity square. So it is also P square over 8. So since the area of an efficient rectangular section is the same as that, therefore, we don't need to evaluate Q of efficient triangular section because it will be the same. So Q of triangular section will also be 1 over 32 perimeter to the 8/3, S to the 1/2 over N. Because percentage increase is 0% because they are equally efficient. Then for an efficient trapezoidal section, the perimeter is 3B, the depth of flow is B cosine 30, B cosine 30. The area, so B is perimeter over 3. The depth is perimeter over 3 cosine of 30, and cosine 30 is square root of 3 over 2, so it is square root of 3 over 6 of B. And the area of efficient trapezoidal section is 1/2 top width plus bottom width times depth, which is B cosine 30. So it is equal to 3 square root of 3 over 4B square. Replacing B in terms of perimeter, which is perimeter over 3 quantity square. Simplifying, it is equal to square root of 3 over 12 perimeter square. So therefore, the Q of an efficient trapezoidal section is area square root of 3 over 12B square raised to 5/3, S to the 1/2 over N perimeter to the 2/3. So still the power of perimeter is 8/3. Let's just evaluate square root of 3 over 12 to the 5/3. If simplified, simplified, but if not, decimal. So Q of trapezoid is 0.0397716 perimeter to the 8/3 over S to the 1/2 over N. So therefore, since this is the common factor, the percentage increase is quantity 0.0397716 minus 1 over 32 times 100% over 1 over 32. That's for rectangular section 1 over 32, the coefficient here. So percentage increase in Q is 27.09% if the perimeter is fixed for all efficient sections. Finally, for efficient of all sections, which is semicircular section, the perimeter is pi r, so the radius is p over pi. The area is pi r square over 2, replacing r by p over pi, quantity square. Simplifying, it is p square over 2 pi. So that's the area. So substitute into the formula Q of semicircular section is perimeter square over 2 pi to the 5/3 s to the 1/2 over n perimeter to the 2/3, and evaluating 1 over 2 pi to the 5/3 in decimal. So it is 0.046741 perimeter to the 8/3 s to the 1/2 over n. Therefore, percentage increase is expect greater percentage because this is the semicircular section. Quantity 0.046741 minus 1 over 32 times 100% over 1 over 32. So that would be 49.57%.